In this tutorial, we will describe one type of instrumental analysis, which is atomic spectrometers. Spectrometers are expensive machines that analyze the energy in the form of electromagnetic radiation such as light, absorbed or given out by a sample. Atomic spectrometers are used to detect which elements are in a sample. So light will pass through the sample. The sample will absorb and will give out some light, and based on this, we can identify the chemical elements present in this sample. The sample will be heated in a flame. Any molecules of compounds that exist in the sample are broken down at this stage. The energy from the flame causes electrons in the atoms of the sample to jump into higher energy levels or shells. So the flame will provide energy. This energy will be used by the electrons of the atoms of the molecule to move between the energy levels. The electrons will move from energy levels near the nucleus to higher energy levels. So they will become far from the nucleus. When the excited electrons fall back to a lower energy level or shell, they give out a pulse of energy that we detect as light of a characteristic wavelength. Because there are a number of different electrons in the atoms of each element, pulses of light at a number of different wavelengths are given out and can be detected by the spectrometer. This is an atom, and this is an electron in one of the energy levels. Let's move this electron to energy level number 2. Because it moved to an energy level which is far from the nucleus, energy is absorbed. If we move it to energy level 1, energy will be absorbed as well. Whereas, when it falls to a lower energy level, for example from 1 to 2, energy will be released. From 2 to 3, energy will be released as well. The energy given out at the different characteristic wavelengths is called the emission spectrum of the element. Each element has its own characteristic emission spectrum. We can see these as lines in a spectrum or as peaks when analyzed by a detector and fed into a computer. So we will measure the energy released when electrons fall to lower energy levels, and we will identify the wavelengths of this energy. This will allow us to plot the emission spectrum of the element. And of course, each element has its unique emission spectrum. So that's how we will be able to identify which element is present in the compound. So this is the emission spectrum of mercury. For example, if we take that of hydrogen, it will look different than this one. Let's describe now the visible ultraviolet spectrophotometers. We use visible ultraviolet spectrophotometer to analyze which compounds are present in a sample. The sample isn't broken up by any harsh treatment in the machine, such as heating it in a flame. Instead, light is shone on the sample, then the wavelengths that are absorbed are analyzed. So, in visible ultraviolet spectrophotometers, there's no heating or flames. Instead, we will use only light, and we will examine the light absorbed by the sample. So we are not examining the light given out, we are examining the light that the sample had absorbed. So this is a light source which will send light to the sample. The sample will absorb certain wavelengths of light, and then the light detector will send the data to a computer to plot a graph showing the wavelengths that the sample absorbs. So we will obtain an absorbance versus wavelength graph. The pattern of wavelengths that is absorbed by the sample is called its absorption spectrum. This absorption spectrum can be matched or fingerprinted against known samples and thus be identified. Even complicated mixtures of compounds can be successfully analyzed in this way.